So here's a common problem on Aleks. If you want to go ahead and pause the video so I don't have to make this a long bit here. Then I'll move on to solving it. So I hope you got that down. When it says this pH 1260, you can totally use the pH plus pOH equals 14, but the problem is with Aleks, and you don't need to know this for the exam. You just need to know it to solve it. Aleks, they are using 1.01 times 10 to the negative 14th instead of what the professor uses, which is 1 times 10 to the negative 14th, which means that you have a discrepancy of 1/100th in a log, which can actually convert into like a big mess and give you an answer that's off, and Aleks won't accept it. So maybe you've run into that problem when you're doing the practice. If you haven't, you probably will. But anyway, if you're going to do pH, pOH, this is the way to do it. Instead of doing pH versus pH plus pOH equals 14, you're going to do this. You're going to do pH plus pOH equals, oh, I put 3 lines. Sorry, I have dysgraphia. Negative log of the factor that Aleks uses, which is 1.01 times 10 to the negative 14th. This differs from the professor's notes. She uses 1 times 10 to the negative 14th. She doesn't include this decimal here. So that's why your calculations are going to come out wrong on Aleks. You're doing it correctly. But once you do this, what this winds up equaling is this number is not 14, it's like 13.99 and a whole bunch of other numbers. But all you got to do is make this change instead of 14, and then pH plus pOH will give you exactly correct answers. So from this, when we take the 12.6 pH and we subtract that from that 13.99 whatever number, I guess I should show you just so that it makes perfect sense what I'm saying. We do negative log of 1.01 times 10 to the negative 14th. That's going to equal 13.99567863 instead of 14. So I'm going to subtract the 12.6 pH, and that gives me a pOH of 1.3956788626. And if you don't understand exactly what pH and pOH are, I need to do like a separate video on exactly what those mean, because it's kind of critical that you understand what they mean. I think you probably get that though. Anyway, once you get to this pOH, you can do 10 to the negative power of 1.3956, which is what gives you the concentration of OH. That means that this number, 0.040208, blah, 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 that's the molarity of OH in the solution. The molarity, which means the concentration. Right? So then in order to find out the actual number of moles, we take the concentration and we multiply it by the volume in liters, which in this equation, in this question I should say, notice that the solution is 550 milliliters, which, because molarity is calculated with liters, we need to do a conversion. That's going to be 0.55 liters. So when I multiply the molarity that you see here by 0.55 liters, I get the number of moles of OH, which is 0.02211, so on and so forth. So check that in your calculator, make sure you're getting the same thing. And then remember that in this equation, if you were to draw out the equation, you would see that the moles of OH to the moles of NOH is a 1-to-1 ratio. So that means that this number is going to be equal to the number of moles of NaOH. It is the moles of OH, and it is also the moles of NaOH in the reactants. And what they're asking for is the number of grams needed, the mass of NaOH, which, by the way, that's sodium hydroxide, if you missed the nomenclature there, which is what they're asking about. So now all we have to do is figure out from this how many grams we have. But keep in mind, this is the number of moles, not the number of grams. I was going to say in a liter, but it's not. We actually already did them 0.55 over here. So this is actually the number of moles in the solution. So the rest of this is so easy, right? I know that you know how to do this. We figure out how many grams per mole. So double check my grams per mole calculation. I think it's 40 grams per mole. I could probably screw that up though. And if I multiply 40 grams per mole by the number of moles, which is right down here, 40 grams per mole times the number of moles, then it tells me the number of grams of NaOH in my solution. It doesn't matter if that's how many the chemist needs to add, or if that's how many we're figuring out we're already in there. It's the same math. It's just a matter of wording, right? That's the number of grams in order to get to these numbers. Oh, this thing is so annoying. Why doesn't it focus? Focus.